More than 9 decades of serving the nation. Central Board of Irrigation and Power.
I retired from Power Grid Corporation of India Limited in 2015. Have you heard the name of this company?
Yeah.
Huh?
We are working
with consultant also.
Okay. Achha. Power Grid has got a job there also.
Yeah, we have Power Grid as a consultant.
Okay.
We have a company NEA and Power Grid 50/50 joint venture.
Okay. Good. So I would like to know which area you have been working, so that I should not go out of the way.
Transmission line and substation.
Transmission line and substation. So you people are all posted in the site or in the office site. So more practical. Okay, good, very good. So do you have any design experience?
Actually, we are jack of all and master of none. So we have to deal with each and everything, right from the land acquisition to the.
Yes, it is mostly the people at site in Power Grid also have to do like that only. Okay.
We normally do review of the designs.
Review
for
of the
final
designs.
approval.
Okay, for final approval. Okay. Anyway, so I feel my presentation before you will be mostly in that direction only. So I have not gone into too much of calculation parts. So anyway, you tell me subsequently if you want me to improve the things, so then it can be done. Okay. So initially I am starting with the concept of insulation coordination. What is the insulation coordination? You see, power system. Electric power system has got different components. Different components means one is generator, another is transmission line, and then substation to cater the load. Now, all through the power system, you need to have a proper coordination of insulation level. What is insulation level? That I have defined later. And unless you do it, what is the impact? What is the impact? Impact is very prominent. Your electrical equipment are likely to lose their lifespan, number one. It is not quite. Number two, it can fail. Immediately it can fail. It can, over a period of time, it can fail also. So insulation has to be made properly. And properly, a designer may think that I will provide insulation at this much for this much of voltage level. Why voltage level is coming? Because it is the voltage which predominantly stress the dielectric strength of the electrical equipment. Dielectric stress, voltage causes dielectric stress. I am not getting into the current part also. Suppose current is more, ambient is more, degree centigrade is more, then what is likely to happen? There will be a heating effect. That heating effect also causes deterioration of the insulation properties. That is another aspect. But this insulation coordination, purely it takes care of voltage stresses. So, you have to design, you have to choose a system with proper insulation level at all, in all components. Now suppose, to be safe, you choose a very high insulation level. What is the impact? Your cost is going to high. Suppose for a transmission line, you have chosen a very high insulation level. What is going to happen? You see, number of discs will go up. Number of discs goes up, that means weight on the cross arms will increase. Or cross arms of weight will be increased. That means cross arms have to be strengthened. Then again better. Tower weight goes up. Would you like it? So things have to be very much economical. Until and unless your design is economical, engineering does not have any meaning. That you have to ensure. So that is the reason. Now another aspect, transformer. You design it for a very high insulation level. You see, it will become very costly. It will become very costly. So you have to have a proper gradation. Gradation in the form of voltage. So that everything is properly coordinated. And then another aspect is there. Surges are going to be there. Surges are going to be there. When surges are there, that has to be absorbed by somebody. What is that somebody? That is surge absorbers. What we normally say is the lightning arresters. Lightning arresters are also to be coordinated in a proper fashion so that discharge does not take place through the equipment. Discharge take place through the surge arrestor, lightning arrestor. So it has to be properly coordinated. When you coordinate, then what is your guiding factor? It's the voltage rating. It's discharge voltage rating. How much is the discharge voltage rating? It decides the proper coordination of the insulation level, proper coordination of the lightning arrestor. Then another aspect comes, BIL. Normally say that BIL. You must have heard that term, basic insulation level. Somebody say it basic impulse level. So that has also to be properly coordinated. Everything. Now, do you have anything to say on this particular slide? Okay. So I am going to the next slide. It was insulation coordination, determination of line insulation. Line insulation. Normally, what do we use? Porcelain insulators. All porcelain insulators have got dielectric strength. Dielectric strength means it can withstand certain voltage level. Certain voltage level under different conditions. Like impulse. Now impulse can be of two types. One is lightning impulse. Another is switching impulse. Another is switching impulse. Have you heard this term? Switching impulse.
Yeah.
Huh? Switching impulse. Another is
No.
voltage trace, high voltage.
Temporary voltage.
Temporary voltage. Not temporary, it can sustain for quite some time also. So you need to have your system properly protected against this kind of voltage parameters. For this purpose, you need to have a proper coordination of the insulation of transmission line. Next, insulation level for, you go to the insulation level for equipment. Now you are entering into the substation. Transmission line is coming to the substation. Then substation insulation level has to be properly graded. Then selection of surge protecting device. It has to absorb this. It has to absorb. So that's why the surge protective devices have to be properly coordinated with that. Now what is the insulation level? This is the minimum voltage rating, both power frequency. I have said now that steady state, more voltage can be there. Suppose your system is not having load. You have heard of one term when you were in college, Faraday effect. Faraday effect. So voltage will go up. And normally in our system, over voltage to the extent of 10%, we allow as a normal phenomenon. That is the reason for 220 kV system, what we say the highest system voltage, it is 245 kV. For 132 kV system, you have got 132 and 220, not 400.
We have 400.
You have got 400 also. Okay, 400 kV it is 420 kV. Okay. So 132 kV is 145 kV, 220 kV is the highest system voltage is 245 kV, and 400 kV it is 220 kV. It is like that. Now, this voltage levels do have different withstand capabilities. Withstand capabilities means it is impulse one. Impulse means lightning impulse, and then it can be switching impulse, and another thing is that power frequency withstand voltage. Okay, so this are to be properly specified. So any question on this particular slide? No. Then go to the next slide. Impulse voltage. Impulse, lightning, it is a quite normal phenomenon. Normal phenomenon. Lightning, you are in hilly area mostly. So before I forget, because I do not know what is the profile in Nepal. Things have been prepared considering the Indian environment and the international. I tell you one thing, I have not mentioned anything on this particular issue, anything here. Remember one thing, if your altitude is more than 1000 meters from the mean sea level, then you have to correct your clearances. By how much? Do you have any idea? Indian standard says it is 1.25% for every 100 meters. Suppose I have stipulated some clearances of 2.8 meters. Suppose you are at an altitude of 1200 meters. Then 2.5% you have to increase that. 2.5%, 1.25 per 100 meters. So 200 meters, so 2.5%. You have to increase your clearances. This you must keep in mind. This I have not mentioned anywhere in my presentation before.
Ground clearance increases or not?
All clearances. Because what is the basic funda? Basic concept is that insulation has to be higher. Altitude is higher, insulation has to be higher. Reason is, up to 1000, all clearances, whatever has been done, these clearances, what these clearances provide you? It provides you external insulation to the equipment. External insulation. There are two types of insulation. One is internal, another is external. Internal means transformers, inside, oil, paper, and all these things, motors, all this oil insulation. And this is external insulation. External insulation, what it is? It is that creepage, number one, air. So, altitude is high, then adjoining air may puncture. That is the reason you have to increase the clearances. Until unless, 1.25% per 100 meters. And this is limited up to 3000 meters altitude. It is not the both sides I have told you. Above 1000 meters, but below 3000 meters altitude, you have to correct your clearances by 1.25% per 100 meters. This you have to. Now, this transmission line, lightning impulse. What is this lightning impulse? Lightning phenomena. Now, different standard bodies are there. India is having one, UK is having one, then US is also having one. So, in India, we have chosen this 1.2/50 microsecond. What does it mean? It is explained here. In US it is 1.4/40 microsecond. UK something different. That is 1/40 something like that. So different standard bodies have. What basically it says? What basically it says? It is the stiffness of the impulse wave. In India, you see, it is 1.2. That means in 1.2 microsecond, it is reaching the peak. Now suppose this is 1 microsecond, then it is further stiff. So based on this, the insulation level is decided. This is the test voltage. We have adopted 1.2. And what is this? What does it mean 1.2/50 microseconds? It is this. Big value, it reaches from 0, it reaches in 1.2 microseconds and falls to 50% of the big value in 50 microseconds. This is the interpretation. It is value. So, now, this is one thing. This is a characteristic of the voltage waveform of the impulse voltage. Now, how does it impact? Next, let us go to the next slide. You see, I have told that altitude is high, you need to correct it. Why? Because atmospheric pressure is different, ambient temperature is different, humidity is different. So, all these parameters affect your dielectric strength. Okay, temperature 1000 meter up to 1000 meter, we are considering a temperature of 20 degrees Celsius.